Hey everyone, Active Learning here. Welcome back to another video. In today's video, we're going to talk about text preprocessing for natural language processing. This will be part of my Introduction to NLP series. So if you want to learn more about NLPs, I'll be releasing more videos on it in my future videos. So let's jump right into what we're going to talk about. So text preprocessing is basically the first step you'll perform for any NLP project. And in this video, we're going to discuss the techniques and steps you will do for text preprocessing. So here are some of the terms that we'll be discussing today and why they matter. And after this video, you will understand every single one of these terms in depth. Right? So let's jump right in. The first term is called tokenization. So tokenization is simply the process of breaking a text into different words. So what do I mean by that? Well, let's start with an example. Say I have this sentence, how are you doing? Well, if I apply tokenization, it simply transforms it into different words, right? I have the word how, I have the word are, I have the symbol question mark, right? These are also broken up, right? So these are individually called tokens, but we don't have to get into the nitty gritty details. But yeah, tokenization, very simple. We're simply breaking a piece of text into words. Okay. In our example here, without tokenization, the sentence will be treated as a single string of characters for our NLP model. However, with tokenization, this sentence will be broken into individual words which have different meanings, right? How, are you, right? Each of these have individual meanings, right? And then these words can then be processed and analyzed by other NLP algorithms to determine the part of speech, the meaning, and other linguistic properties of each word, right? Another thing is that tokenization also helps with standardization. So what do I mean by that? Well, okay, yeah, this was meant for the above. Okay, so say we have these two colors, these two words, sorry. They both sound like color, right? Well, they also mean the same thing, depends on which country you're from. Let's say I have color and color. Uh, and these two words will be standardized to a single one through the process of tokenization. And so you might be wondering, why does this matter? Well, standardization can improve the accuracy of our NLP algorithms and make the results more consistent, right? We'll be treating these two as the same word, right? It doesn't matter if this word is color or color, they're the same, right? If we standardize it through tokenization. Okay, now our next step is called stop words. Okay, so in order to understand stop words, let's first look at an example, right? So let's say I have this sentence, hey man, I can't come to your house tonight. In this sentence, there are only a few words that we actually really care about in order to understand what the sentence is trying to convey, right? In other words, this sentence will still capture the main idea if we remove some of the words. All right. So, for example, we can remove hey and we can remove man because they don't really convey anything that changes how we interpret this sentence. And, we don't need the word to come to your house. We don't need the to there. And the sentence remaining is I can't come your house tonight. And that basically allows us to interpret what the sentence is trying to convey without some of the words, right? Now, you might be wondering, why does this matter? Well, it makes our algorithm faster since we don't have to process some of these nitty gritty details, right? And now, the term stop words should be very intuitive because we're simply stopping certain words from entering to our preprocessed data, right? Okay, now we got that over with. So you might be wondering, how do I actually stop these words from entering? Well, most libraries can actually do most of the job for you. But if you want to stop certain words on your own, for example, you have certain words you don't want to include, then you can actually just make a list and then look for them and then just remove them, right? It's simple as that. Uh, okay. But okay, so back to our sentence. Um, the word can't in this example is actually very important because it indicates that the opposite action will occur, right? Without this can't, it will be I come your house tonight, right? But with this word can't, it means that I can't come to your house tonight. So it indicates a completely different meaning. That's why this word is so essential in this sentence, right? So there are certain words that we will value over others in this case. Right. Can is very important word because it indicates that the opposite action will happen. Okay, so our next action or step is called stemming. Actually, stemming and lemmatization are both steps you can take, but let's first talk about stemming, right? So, in order to understand stemming, let's first start off with an example, right? Let's say we have these two words, history and historical. And in our case, let's just say they mean the same thing, even though in certain contexts they might mean different things. And here we can apply stemming and we get the word history, right? Since history is shared by both of these words, right? We can consider this the stem of these two words. And you might be wondering, well, what does this word history mean? Well, it doesn't actually mean anything. And that's actually one of the disadvantages of stemming because we might get words that mean completely nothing, right? Okay. So then you might be wondering, what is the point of using stemming if it is flawed? Well, the answer is that stemming is blazing fast, right? It will help us with text preprocessing for huge data sets, right? So we don't have to worry about these different words. We can assume that they mean approximately the same thing, right? See, the advantages is that it's really fast, which helps with pre-processing huge data sets. And you often have to work with huge data sets when you're working with NLP. So stemming is very much used. And some of the disadvantages is that certain words can be meaningless, right? For example, history is meaningless in this case. But yeah, it completely depends on where you're applying NLP to. We'll discuss this later. Right. Now, our next step or term is called lemmatization. And what it basically does is that it overcomes the disadvantages of stemming. Okay, so lemmatization basically does the same thing as stemming, right? Except now we are converting the similar words into meaningful words, right? In our case, it will be converted to history, which is a meaningful word, right? You know, originally from stemming we had the word history, but now we get the word history, which actually means something, right? Well, you might be wondering, how is our model able to do that? Well, it basically has access to the entire dictionary. That's why it compares a lot of different terms or definitions to get the one that's the most similar with our case here. And that's how it's able to do that, right? Then you might be wondering, well, why don't we use this instead of stemming? Well, there's a trade-off, right? So the advantages is that it's accurate and provides meaningful words, while the disadvantages is that it's really slow because it has to compare a lot of similar words, right? That can be very slow for a huge data set. So you might be realizing that, oh wow, so stemming and lemmatization have different advantages and disadvantages that each of them sort of overcome for the other. So then you might be wondering, well, which one should I choose, right? Well, that actually really depends on the use case, right? So let's look at the stemming versus lemmatization use cases. Okay, so for stemming, we usually use it for spam classification, right? Because the accuracy of each word don't matter as much in this case. And for common toxicity classification, um, I guess the meaning for each word might not matter as much, right? But for lemmatization, we might use it to summarize text, right? Because we care a lot about the accuracy. And we also use it for chatbot because we want our chatbot to actually give meaningful responses, right? We don't want it to misinterpret something. And we also use it for translator, which, you know, values values accuracy a lot, right? So these are the certain use cases, and you kind of have to determine which one you value more, right? Do you value speed or do you value accuracy? Because if you have a huge data set, you might want to value speed over accuracy. But if you have a small data set, then you might want to value accuracy over speed, right? So, you know, throughout machine learning and deep learning, there are tons of trade-off, and this is one of them, right? You kind of have to consider which one is more important to you. And yeah, that's it for this video. We talked about tokenization, we talked about stop words, we talked about stemming. So now let's quickly just recap, right? So tokenization is basically breaking each sentence into individual words and symbols in order to make them mean different things in different contexts, right? Instead of the sentence being analyzed together, we'll analyze each individual word, right? And each individual word have different meanings, right? And stop word is that we're basically canceling the words that we don't really need to interpret our sentence. And we're keeping the essential ones, right, that allow us to actually interpret what the sentence is trying to convey. And then we talked about stemming, which is basically trying to find the similar stem for different words, right? And then we're converting those words to the stem, right? The advantages is that it's super fast and it helps with processing huge data sets. The disadvantages is that it can be uh, inaccurate, right? Providing meaningless terms. And for lemmatization, we talked about this. It provides accurate and meaningful words, but it can be really slow because it has to compare a lot of similar words, right? So yeah, that's it for this video. I'll be doing more NLP videos in the future. NLP will take a long time to actually discuss because it's a pretty big field, right? So yeah, that's it for this video. I hope you guys enjoyed this video and found it helpful. And yeah, if you want to support me, you can like and subscribe to this video. And also, you can check out my other videos where I talked about deep learning and sort of computer vision, transfer learning, that sort of stuff. So yeah, that's it for this video. See you guys next time. Bye.